Population health involves the well-being of individuals in relation to distribution outcomes within a specific group. To understand a population's health needs, healthcare organizations must collect, analyze, and extract insights from extensive datasets. These datasets include both structured and unstructured data, such as social determinants and even genomics. This demo shows an AI-powered guide that helps healthcare providers interact conversationally with data stored in AWS HealthLake. It gives care teams the ability to gain a holistic patient-level view to address individual patient needs. It also extends the analysis to a population level, identifying associated risk factors and determinants. This example uses the open-source large language model, or LLM, FLAN T5XXL, available on AWS. The care team member or clinician asks the guide, what medications does the patient take? In the background, the guide generates a SQL query and then runs that query against the AWS HealthLake database. The LLM generates the response and highlights the source of this data. In this scenario, since seizure medication can change the metabolic processing rate of nicotine, the clinician asks the guide about Tommy's smoking status. This would usually require a clinician to manually review the patient's vast health data to find the answer. The guide simply pulls the information from unstructured health data using Amazon Kendra and quickly responds that the patient has never smoked. The clinician then explores whether this medication may be cost prohibitive for the patient by asking for the average cost of the medication. The guide provides this average. Next, the clinician seeks social determinants that might determine Tommy's ability to afford the medication. They ask, search doctor's notes for Tommy 814's socioeconomic status. The guide replies, Tommy 814 comes from a middle-income socioeconomic background. Because this information is critical to learning if Tommy can afford this life-saving medication, the clinician can directly access the underlying data sources to review the notes in more detail. Based on the medication's costs and Tommy's socioeconomic status, the clinician can then build his treatment plan to include not only medications, but also an intervention plan. They can build frequent touch points into the plan to verify his continued access to the medication. They note that middle-income individuals may have a higher probability of intermittent financial constraints, which could lead to life-threatening gaps in treatment. This guide can help clinicians explore personalized treatment and intervention plans. Individual patient parameters are considered, and extrapolated population-level insights are pulled from various data forms. This integrated approach supports more informed clinical decision-making, as well as better evidence-based treatment protocols that are tailored to each patient's needs.